Hello, and thank you for contacting Wave Support. I see from your clinical request you're struggling a little bit with the fit and the vision in this keratoconus patient. And looking at your designs, these are some of the most challenging cases sometimes because you have a great looking topography and you've got a lens design that looks pretty much picture perfect based on traditional wave fitting techniques, and then it gets frustrating when we have a fit that's less than optimal and the vision that's blurry. So let's talk about a couple things that may be contributing to this. From your request, you suggested that the lenses tend to slide down, and you get some pulling inferior and bearing on top. And that would make sense if these lenses decenter, because you're going to have a steeper area in the central part of the lens, and as that lens drops, it's going to create an area that looks like it's pulling down here, and this flatter part of the lens will start rubbing up against this cone, giving you that little bearing area. So that would make sense with the fact that you get that type of fluorescein pattern. So one of the things that you want to do is get these lenses to center better, and your thought about trying to make them larger certainly is very helpful. In some of these cases, I go as large as I can possibly get away with. Going up to 11.5 or so diameter will probably help out. The other thing you can do is sometimes moving the where those control points are, the red and the blue. I would have started exactly where you did by placing that red dot somewhere around the center part of the steepening part of the cornea, just as we are traditionally taught in wave designs. However, sometimes trying to move that out a little bit further, instead of being at about 3 or so, maybe taking out to 4.5 to 5, and then spacing the blue maybe 1 to 2 outside of that. Sometimes that will be helpful, just moving it a little bit out, and also sometimes using a little S factor. Asphericity can sometimes help that lens align a little bit better on the eye. But I think getting larger will help push that lens more centrally and help keep that fit a little bit nicer. With that said, if you end up failing continuously, you may even consider going to a mini scleral lens. Sometimes I found that those will be helpful in these cases where these on-cornea designs just make no sense as far as the relationship with the cornea. And if you haven't done one of those yet, there's a really nice wave tutorial. It's called using an 8-point fitting technique. I'll leave a link on the email for you to view if you need to reference that. As far as the power goes, as you know, these cones create some unusual refractions, and most likely what's happening, especially if your best correctable visual acuity is down as much as it is, it would suggest that that refraction is probably not the true refraction of the eyeball. The astigmatism is probably more induced from the cone. So therefore, when you create a free-form design that's so complicated and sophisticated, you end up with a lens optics that really is not truly representative of the eye itself. So in those cases, what I like to do, I like to place a trial lens on the eye of a known spherical design and power and get an over-refraction from that lens, and then take that data and under Tools, Trial Lens Data, enter that information in here, and that quite often will help correct some of those optical problems. In some cases, if I just can't make any progress, I find it helpful sometimes to just either leave out the refraction, so that way you're not introducing poor data, and then still use this trial lens data technique to get the lens power accurate. Hopefully you'll find that helpful. I wish you well with this complicated case. These can be very challenging. Don't get discouraged, but I wish you well, and thank you for contacting Wave Support. Have a great day.